Ian Stewart, GMAT math expert, tutor and writer, and this video is part of a series of videos I'm doing featuring high-level questions that I've designed. This video is really not meant for everyone. It's meant for test takers who have already studied the topic and who are scoring at a Q40 level or above. So if that's not you, then just bookmark this page and come back when it is. My questions, they're not modeled after published official questions. Instead, they're much more like what you'll see on test day, questions testing the same familiar GMAT concepts, but in unusual or inventive ways. And the questions are quite challenging, so don't be concerned if you find some of them difficult. To get the most out of this video, you should try each question. I'll put each on the screen for 5 seconds, so press pause. But if you get stuck, don't spend more than about 90 seconds on any one problem. So we have a list of consecutive integers. So we have an equally spaced list, and in any equally spaced list, the average is always equal to the median. And this is sum of any set at all, just by the definition of the average. The sum is always equal to the average times the number of terms. So the average is the median, and the number of terms is 21. So the sum of our list must be 21 times the median. But we have an odd number of things in our list, and so our median must be in our list somewhere. And our list consists of integers, so our median must be an integer. If our sum is 21 times m, 21 times some integer, our sum must be a multiple of 21. And if statement 1 is true, the sum is between 400 and 440. Well, there's only one multiple of 21 in that range. 420 is 21 times 20. So the sum absolutely must equal 420, and statement 1 is sufficient. Statement 2 tells us the smallest value in the list is either 9 or 10, but of course, the larger the smallest value in our list is, the larger the sum will be. So we have 2 possible values for little s here. We can't possibly find one unique value for the sum of all the integers in the list, and statement 2 is not sufficient. If we take any set at all and just add 20 to every value in the set, then none of the distances within the set will change at all. Every value gets bigger, but they're just as far apart as they used to be. So the standard deviation in statement 1, that won't change, and the distance between Farah's grade and the average won't change either. If she's more than one standard deviation above average after we increase every grade by 20 points, she was definitely more than one standard deviation above average before we increase all the grades by 20 points, and statement 1 is sufficient. In statement 2, the distinction here, we're increasing every grade by 20%, which means we're multiplying each grade by 1.2. So here we're multiplying rather than adding. And when you multiply, you stretch distances out, or shrink them if you multiply by something less than 1. So in statement 2, after the grades are increased, the standard deviation will increase by 20% also. But so will the distance separating Farah's grade from the average grade. All of the distances will scale upwards by a factor of 1.2. So if she's more than one standard deviation above average after doing that scaling, she would have been more than one standard deviation above average before scaling the grades in that way, and statement 2 is also sufficient, so the answer is D. So here we have something that technically is known as a geometric sequence, but you don't need to know what that means for the GMAT. We're just multiplying by r each time to find the next term in this list. So a times r times r, which is a times r squared, and so on. And first, if you just imagine everything's positive, then if we just keep multiplying by some positive number r, as long as that number is not 1, then our terms are either just going to keep getting bigger and bigger, or they might get smaller and smaller if r is some fraction close to 0. And so if everything's positive, this list is either going to continually increase or continually decrease, and the median will be the term that is visually in the middle of this list, the third term, AR squared. So that can definitely be the median. But there's another possibility we need to consider. R might be a negative number here. And if R is negative, every time we multiply by R, then the sign will flip. So it'll go from positive to negative or from negative to positive. So if we first imagine A is positive, our signs could be in order: positive, negative, positive, negative, positive. And what we're concerned with finding here is the median. So the sort of third smallest or third largest number in this list. Well, if we have 3 positives and 2 negatives, the 2 negative numbers need to be the smallest numbers in the list. Negatives are always less than positives. So in this case, the median would be the smallest of the 3 positive numbers. And because AR squared, and AR to the 4, those are the 3 positive numbers, we're just multiplying by R squared each time to go from A to AR squared to AR to the 4. Well, those 3 terms need to be kind of constantly increasing or constantly decreasing. So the smallest of the 3 needs to be either A or A times R to the 4. So either of those could be the median in this case. And the only remaining possibility, we might have the sequence of signs negative, positive, negative, positive, negative. In which case the median, similar to the previous case, the median will be the largest of the 3 negative numbers. And just analyzing it in the same way, that's going to need to be either A or A times R to the 4. So it's impossible for AR, item 2 in the Roman numeral list, to be the median, but A can be the median and AR squared can be the median, and the answer is 1 and 3 only. If you enjoyed these questions, I've written 4 long problem sets full of high-level questions like these, along with a set of books covering all of GMAT math that teach my conceptual approach to the test, which is perfect for high-level test takers. And if you're interested in any of that material, you can just visit my website. The link is in the description below.